Now let's take a look at horizontal shifts. Horizontal shifts are left-right shifts. These shifts are created by adding a constant value to the variable, to the input variable, in a known function. Using function notation, we might write the following. Given y equals f at x, we have a horizontal shift when we can write g equals f at x plus h. So notice the addition of the quantity is actually inside of the parentheses. Again, to best illustrate this, let's take a look at f at x equals x squared, a familiar function. So again, I graphed f at x equals x squared. Again, we know what it looks like. Let's take a look at what happens, though, if I look at b of x equals x minus 1 squared. If I put that in my calculator and I graph it, what I happen to notice is it picked up the entire y equals x squared graph and moved it to the right 1 unit. So it moves the whole thing to the right. Even though it looks like subtraction, it doesn't move it to the left. When we have the minus on the inside, it moves it to the right. So inside, it's a right-hand shift with the subtraction. So notice actually then what happens is this affects the x values, not the y's. So the point AB gets shifted to the point A plus 1. Again, we're shifting to the right. So to shift to the right, we add 1 to the value. Notice it's a little confusing. We see a minus 1 in the parentheses, but the actual effect is a right-hand effect, which adds 1 to the x value, but it keeps the y value the same. Let's take a look at a third one. C of x is x plus 2 squared. If I put this in my calculator, it picks what it notice happens is it's as if we picked up the x squared function and moved it to the left 2 units. So again, it's the opposite of what we see in the parentheses. The plus 2 means a left shift of 2, and it affects again the x value, not the y. To actually find the coordinates, to get the left shift, we subtract 2 from the x coordinate and we keep the y coordinate. So in summary, if y equals f at x is a function and k is a constant, then the graph of y equals f at x plus k or h or whatever I want to use is the graph of f at x shifted either left or right k units. Some students think of it, oh, it shifts the opposite of what I see. Notice what it does is if it shifts to the left, we subtract from the x coordinate, but it appears almost as if it's addition inside the parentheses. Similarly, if we shift to the right, we actually end up adding to the x coordinate, but in the original equation, it looks like subtraction is going on. A little bit confusing. So the shifts here, once again, are counter to what you probably expect to happen. In other words, we need to be careful. A positive k shifts a graph in the negative direction, and a negative k shifts the graph in the positive direction. This is exactly opposite to what we saw with vertical shifts. It's really easy to get these flipped around and shift incorrectly if you're not being careful. So again, if we see a plus k, a positive inside the parentheses, we shift left k units. If we see a negative inside the parentheses, it looks like subtraction, we shift right k units. Just like I did before, I could take a look at the tables. So again, I did the x squared table. Then I did an x minus 1 squared table. Notice again, the x minus 1 means shift to the right. So when I shift to the right, and I did this a little bit differently in the table, what's really going to happen is it's as if I took the whole table and moved it. So if, for example, I took a look at this point, negative 2, 4, if I shift to the right, that's the one that actually becomes negative 1, 4. So I add 1 to the x's because I'm shifting to the right. This negative 1, 1, the y stays the same, but the negative 1 I add 1 to, and that gives me 0, 1. This 0, 0, I add 1 to the x value, gives me 1, 0. This 1, 1, I add 1 to the x value, gives me 2, 1. This 2, 4, I add 1 to the x value, that gives me 3, 4. Notice if I look at y equals x plus 2 squared, that's the shift to the left. So notice if I shift to the left, what happens? If I come up here, for example, and here's my 3 value. Again, this is an inside shift. It affects the x's. So if I start with my x is 3, and I shift to the left 2, I get the point 1, 9. So here's the 1, 9. If I have 2, 4, and I shift to the left 2, that's going to give me 0, 4. If I have 1, 1, and I shift to the left 2, that's going to give me negative 1, 1. If I have 0, 0, I shift to the left 2. It gives me negative 2, 0, and so on. So when we add or subtract a constant within the domain region of the function, we'll call this a horizontal shift, or I'll call it an inside shift, because if you look at the function, it looks like it's happening inside the parentheses. The effect this has on the table is it shifts the x values left when k is positive, and it shifts the x values right when k is negative. This is very, very tricky.